This video will focus on how main group atoms ionize. So when it comes to ions, we've already talked about how they are atoms that have either gained electrons to become negative or lost electrons to become positive. And again, remember, chemistry is explaining what actually happens. And when we observe atoms and look at what ions they create, what we notice is that atoms in the main group areas, so those atoms in the S block and the P block, they tend to gain and lose electrons in order to become isoelectric with noble gases. So that means they gain electrons to become like that P6, or they lose electrons so that their outer energy level becomes P6. So we always want a full S and a full P. So 2 plus 6 then for 8. So that's kind of where this octet idea came from, if you've ever heard it before. The P and the S just divide now into sub-levels. So when it comes to ions, there's two different types of ions. There's a cation and an anion, and I can guarantee you're never going to forget which is which, because cations, those are positive ions. So cats have pause, cations are positive ions, those are the ones that lose electrons. Anions are then the other ones. They're the ones that gain electrons, become negative. I don't have any cute way of remembering that. You just got to remember it. So the pattern in terms of how atoms gain and lose electrons to become like noble gases corresponds to the periodic table. This whole unit's about how you can use the periodic table to find things out. So that entire first column of the table, the alkali metals, they have an S1 electron. If they lose that one S electron, they become isoelectric with noble gases. So the first column tends to make a +1 ion, losing the S1. Second column, the alkaline earth metals, they tend to lose 2 to become a +2 as they lose their entire S2. We're not dealing with the middle atoms here because they're not part of the main group elements. They're also variable because of the D block and the half-filled and the P's and everything like that. They potentially have multiple charges, like copper does a +1 or a +2, and iron does a +2 or a +3. So in all those cases, you can't use the periodic table to predict what they will do. So if we jump over to column 13 with boron and aluminum, they tend to make a +3, losing both S's and then their 1P. Once you travel down to like gallium and indium and things in that column, they don't follow a pattern. So boron and aluminum do +3, but after that, they don't. So the staircase here kind of divides out what charges happen. Column 14 doesn't do a charge. They don't tend to make ions. They would have to lose 4 or gain 4 to become isoelectric with a noble gas, and it just doesn't happen. In real life, carbon and silicon don't make ions. So we're not going to learn anything about those. Now if you go to column 15, we get to a point where it's easier to lose 3 electrons than to gain 5, because gaining 5, each electron takes work to get, more energy. So now we flip from losing electrons to gaining electrons. So column 15, they have P3. If they gain 3 more, they become P6, isoelectric with the noble gas, so that's what they do. So nitrogen and phosphorus and arsenic, you can assume, do that. But then below that, the SB and the Bi, they don't do that. Okay, so the dividing line in this case, the top is the pattern we're looking at here. Column 16, -2, because they have P4, so that's how they become P6. Column 17, those halogens, they go -1, so that's how they become P6. And then our noble gases don't do anything in terms of ions because they already have a full S2P6. That's it. Have a nice night.